Hello and welcome to this tutorial on external tangential planes, solids in contact. This podcast was produced by Danny Power, Dylan Quinn and Ray Prendergast. In today's lesson, we will locate the vertical and horizontal traces of the tangential plane in contact with the cone and sphere. We will then locate the line of contact on the cone and will show in the plan and elevation. Lastly, we will locate the point of contact on the sphere and will show this in the plan and elevation. Now, as you can see in the model view on the right hand side, the plane is resting on the sides of two cones of the same inclination. The second cone around the sphere needs to be constructed in order to find the traces of the plane in the plan and elevation. As illustrated in the model view, the plane is a tangent to the traces of both cones. I have taken a screen grab of the model view from another angle. From this angle, you can see that the plane is resting along the side of both cones. To help visualize this in 2D, I have put a sketch in the corner showing the plane leaning along a cone. Now, in order for the plane to lean along the full length of another cone, the other cone must have the same inclination. This can have any height as long as the inclination is the same. The inclination is the angle in which the side of the cone makes with the base of the cone. Now here is a quick view of the full solution to the question we have to answer. Here we have the cone and the sphere and the traces of the imaginary cone. And constructed into the plan and elevation, we have the vertical trace and the horizontal trace of the tangential plane, the line of contact on the cone and the point of contact on the sphere. Now we will start from scratch and locate the horizontal and vertical traces of the plane. Just a tip for when you're doing this at home, use different colors as it will help you to visualize it easier. So, part 1 is to locate the vertical and horizontal traces of the tangential plane in contact with the cone and sphere. As one of the solids is a sphere, the horizontal trace of the plane won't touch off it. It can only touch the sphere at one point as it is a tangent. So what we must do is construct a tangential cone of the same inclination as the other one, and we know that this plane is a tangent to both of these cones. So this is the question you are given: to determine the traces of a plane which shall be tangential to a given cone and a given sphere. You are given a cone with a base length of 40 mm and a height of 35 mm, and a sphere of diameter 20 mm. They both rest on the XY line. As you can see, the center point of the sphere in plan view is 20 mm below the XY line, and the center point of the cone in plan view is 40 mm below the XY line. Your first step is to draft up the plan and elevation on your page with the appropriate dimensions. Do this in a 2B pencil. Once this has been done, you are ready to start the question. So the first thing you do to solve this question is to construct the imaginary cone around the sphere with sides parallel to the real cone. Constructing the sides parallel to the original cone ensures the angle of inclination is the same. The reason we do this is because it enables us to find the point of contact on the sphere, which we will be doing later on. It also allows us to locate the vertical trace. In the meantime, we must finish the imaginary cone in the plan view. We need to construct the cone in plan view because we know that the plane is going to form a tangent to both circles. This, as we know, is because the plane is resting flush against both cones. Therefore, now what we need to do is construct a tangent to both cones in the plan view and extend it back to the XY line. This will give us our horizontal trace. Now just a quick flashback to the junior cert syllabus and the common tangent construction. It is not going to be necessary for us today to carry out this construction to find the tangent. At Leaving Cert level, it is assumed that you can do this construction. However, they want to see that you can do the question at hand. So for the tangent, you would construct it as accurately as you can by eye. This will avoid wasting time and clogging up the drawing with unnecessary constructions. So here we have constructed our tangent by eye, giving us our horizontal trace of the plane. As I recommended earlier, you should use a different color pen to highlight this trace. The next step is to find the vertical trace of the plane. This is where we use the imaginary cone in elevation. Again, I would strongly recommend changing the color of your pen to avoid confusion between all the different construction lines. You construct the line from the apex of the cone for a distance in the direction of where the horizontal trace intersects the XY line, parallel to the XY line. Now we construct a line from the center of the sphere in the plan view back to the XY line parallel to the horizontal trace. Then, where that line intersects the XY line, we bring a line up to where it intersects the horizontal line. The vertical trace will intersect this point. To locate the vertical trace, extend a line from where the horizontal trace intersects the XY line, straight up through the intersection of the horizontal and vertical lines from the cones. So that wraps up the first part of our question and brings us on to part 2, to find the line of contact on the cone. You may be wondering why line of contact and not point of contact. This is going back to the start of the tutorial when I explained that the plane is lying flush against the cone. Hence, it is not only touching it in one spot. First, we need to get the line of contact in the plan view by constructing a normal to the tangent that goes through the center point of the cone. We construct a line perpendicular to the horizontal trace back to the center point. This will give us our normal, and hence will give us our line of contact in the plan view. To find the line of contact in the elevation, we will extend a vertical line from where the tangent and circle intersect up to the XY line, where it intersects the cone. This point is the bottom line of contact. Extend a line from this point to the apex to locate the line of contact in elevation. Now, for part 1 and 2 complete, it is time for the final step in the construction, to find the point of contact on the sphere. Again, like the line of contact, we must first find the point of contact in the plan view. However, the first piece of work is in the elevation. We must construct a line from the center point perpendicular to the tangential side of the cone. Then, we drop a vertical line from the point of intersection down as far as the center line in the sphere in the plan view. Next, we construct a line from the center of the sphere in plan view perpendicular to the tangential plane. Using the compass from the center of the sphere, swing an arc from where the vertical line intersects the center line. Where this arc intersects the radial line, as shown, this will give us the point of intersection in the plan view. Now for the final step in this question, to locate the point of contact in elevation. What we do then is extend a vertical line up from the point of intersection in the plan view through the cone in elevation. Construct a horizontal from the point of contact between the tangent to the sphere and the normal. Where the line intersects the vertical line will be the point of contact in elevation. Now here is a final view of the fully solved solution. Here we have the vertical trace, the horizontal trace, we have the line of contact, and we have the point of contact. And we have all the different colored constructions showing how we got there. This is the end of this tutorial. I really hope you found this useful, and thank you very much for watching.